Dear students, welcome to our lecture series Calculus 2. Today is our lecture 4 and the topic is integrating rational functions by partial fractions. Before going to lecture 4, let me review lecture 3. And in lecture 3, we discussed trigonometric substitution. How can we integrate integral involving radicals? The preceding sign of x square is negative, then the substitution should be like a sin theta. So, for example, for this one, what will be the substitution? In that case, a square equal 4, so a equal 2. Therefore, your substitution will be x equal 2 sin theta, and for this one, x equal half sin theta, and if you look here, root 16 minus x square. So here a should be 4, so x equal 4 sin theta, and for this case x equal 3 sin theta. For this one, since the preceding sign of x square is plus and a square also plus, so x should be 2 tan theta, and for this one x equal root 5 tan theta. For this one, since the preceding sign of x square is plus and a square is minus, so x should be 3 sec theta, and for this integral x should be 4 sec theta, and for this one again x equal root 5 sin theta, and for this one you see you need to cancel 9. So it should be 4 by 9, and in that case your substitution will be 2 by 3 sec theta. So let's start our today's lecture, lecture 4, and today's topic integrating rational functions by partial fractions. And the first question is, what does it mean by rational functions? And the rational function is the ratio of two polynomials, or it's the ratio of two functions. For example, px divided by qx. So it is a rational function. And the next one is partial fraction. What does it mean by partial fraction? So let's see. We can write 5 by 6 equal 1 by 3 plus 1 by 2. So it means 1 by 3 is a partial fraction of 5 by 6. Since you decompose 5 by 6 by the addition of two fractions, and 1 by 2 is another partial fraction of 5 by 6. So 5 by 6 is the original fraction, 1 by 3 is the partial fraction of this one, and 1/2 is another partial fraction of 5 by 6. And partial fraction decompose a rational fraction into a sum of simple rational functions. So let's see, 3 by x minus 3 plus 4 by x plus 2 is equal 7x minus 6 divided by x square minus x minus 6. So one can easily sum these two fractions to get a single fraction. But the question is, how can one come back to the left side if you are given a single fraction? So from a single fraction, the way you come back to the to get the sum of two fractions is the technique of partial fraction. So the question is, how can one decompose or break down 7x minus 6 divided by x square minus x minus 6 into a sum of two fractions? So let me review it again. One can easily move from left hand side to the right hand side. The question is, how can one move from right hand side to the left hand side? The way one can move here is called the partial fraction method. So to do that, one can consider 7x minus 6 divided by x square minus x minus 6 equal a divided by x minus 3 plus 4b divided by x plus 2. So we want to come back from here to here. So that's the reason the a and b is the unknown quantity, and it's an identity which is satisfied for all values of x. Let us consider this equation number 1, and multiplying both sides by x square minus x minus 6, we get 7x minus 6 equal a times x plus 2 plus b times x minus 3. Let's say this one equation number 2. And how can we calculate a and b? There are two methods or two ways you can calculate a and b. The first one is you can just replace a value for x in order to remove either a or b. For example, here x equal 3 gives if you consider x equal to 3, then this part will vanish. So x equal to 3 gives 7 into 3 minus 6 equal a into 3 plus 2. This implies 21 minus 6 equal 5a. This implies 5a equal 15. Therefore, a equal 3. And again, by putting x equal minus 2, we can determine b. So when x equal minus 2, 7 into minus 2 minus 6 equal minus 5b. This implies minus 20 equal minus 5b. Therefore, b equal 4. So this is the one way you can calculate a and b. Therefore, equation 1 implies 7x minus 6 divided by x square minus x minus 6 is equal 3 divided by x minus 3 plus 4 divided by x plus 2. So there is another way you can calculate a and b in equation 2 by equating the corresponding coefficients of x and the constant terms. For let's see, multiply out the right hand side of equation 2, we get 7x minus 6 equal ax plus 2a plus bx minus 3b. This implies 7x minus 6 equal a plus b times x plus 2a minus 3b. So equating the coefficient of x, we get a plus b is equal 7 and 2a minus 3b is equal minus 6. And here you have two equations in two unknowns, a and b. So you can easily solve this system. So solving this system, you can easily determine a equal 3 and b equal 4. So we have 7 minus 6 divided by x square minus x minus 6 equal 3 by x minus 3 plus 4 by x plus 2. So these two fractions are called partial fraction decomposition of this fraction, and this fraction is called partial fraction of this fraction, and another one is called partial fraction of this fraction. This is how you can convert a single fraction into a sum of two simple fractions. So now let us extend this idea into general rational functions, and let us try to understand this rule, which is linear factor rule. If your single rational functions has a factor like this, ax plus b whole to the power m, then your partial fraction will be a1 divided by ax plus b and a2 divided by ax plus b whole to the power 2 and am divided by ax plus b whole to the power m. So, for example, if your original fraction has two factors like this, x minus 1, x minus 2, these are the linear factors. So, your numerator will be constant. So, you have two factors, x minus 1 and x minus 2. This one is linear, so numerator will be constant. For example, a and b. And here you have two linear factors. This one raised by 2. So, the partial fraction decomposition will be a by x minus 1. As for this one, you need to have two simple fraction like b by x minus 2 plus c over x minus 2 whole square. And for this one, you see x minus 1 raised to the power 2 and x minus 2 raised to the power 3. So, it should be like this, 1a divided by x minus 1 plus b divided by x minus 1 whole square plus c divided by x minus 2 plus d divided by x minus 2 whole square plus e divided by x minus 2 whole cube. So, this is the linear factor rule. How about quadratic factor rule? So, now let us try to understand quadratic factor rule. You see, quadratic factor means quadratic equation x square plus bx plus c raised to the power m. So, for this single fraction, the partial fraction decomposition contains m partial fraction. So, you see, for example, 2x plus 7 divided by 2x square plus 3x plus 7 whole to the power 2, it contains two partial fraction, and this one contains, for this one there is one partial fraction, and for this quadratic factor there is another partial fraction. But the most important thing here is that if your denominator contains quadratic functions, then the numerator will be linear function, and if your denominator has linear function, numerator will be constant. If your denominator has quadratic function, that's the reason numerator has linear function bx plus c. So, let us see another example. This partial fraction contains two factors, one is linear, another one is quadratic term which raised to the power 2. So, your partial fraction decomposition should contain three partial fractions. One is for x plus 2, and since x plus 2 is linear, the numerator should be constant, and another 2 is for x square plus 3 whole square. So, x square plus 3 plus x square plus 3 whole square, and since this one is quadratic, the numerator should be a linear factor, and since this one is again quadratic, the numerator should be linear. So, you already used ABC, so it should be dx plus e. So, that's all about the technique of partial fraction.